Hello everyone, today is 2026 Comics, a special episode of the Bluetooth AOA series. Let's insert a demand analysis. For the demand provided by partners, a production line in a factory. For positioning and provide corresponding analysis ideas, I hope it can help more friends.
And we welcome any needs
to discuss with us. We will definitely help you and find the most suitable solution for you. As for using Bluetooth AOA, it doesn't matter. Use it, make a friend. If not, just leave it. And leave a future vision. Let's get started.
Let's dive right in. We're looking at a project for an aluminum plant, specifically about getting precise location tracking inside their massive indoor production lines. The client coreaiot is asking if using Bluetooth AOA technology is the way to go. The big deal here is they need pinpoint accuracy within a tough environment. So, picture this, not just one, but 3 enormous indoor production lines, each stretching over a kilometer long. That's like a small city block laid out horizontally. The space itself is pretty standard, industrial-wide corridors, high ceilings, maybe 10 to 15 meters tall. But here's where it gets tricky. It's packed with metal machinery and equipment. Think of it like trying to navigate a giant maze made of steel. Plus, there's a constant cloud of dust floating around. Imagine trying to keep your phone clean enough for good signal reception. And the hardware we deploy needs to be tough, lasting 5 years without much fuss, and sealed against dust and water. That's the IP66 rating, meaning fully protected from dust ingress and powerful water jets. This isn't exactly a walk-in-the-park setup. Now, what exactly do they need this fancy positioning system to do? First off, accuracy. They're aiming for 1 to 5 meters. For context, that's pretty decent for indoor navigation, especially considering the challenges. It means knowing roughly where you are, not just which general area you're in. Who needs this precision? 2 main groups. The transport vehicles, zipping around, loading and unloading materials, and the people drivers, visitors, maintenance staff, who need to know where they are too, sometimes even figuring out how to get back to where they started. So, the core functions boil down to 2 things: guiding those trucks smoothly along the lines and reliably tracking people anywhere on site. Simple goals, but achieving them in that dusty metal-filled environment is the real test. So, how do we tackle this beast? The proposed solution is Bluetooth Angle of Arrival, or Bluetooth AOA. Now, standard Bluetooth, the kind you use for headphones or connecting to your smart TV, isn't accurate enough for this job. It's more like knowing you're somewhere in the room, not standing by the door. Bluetooth AOA is a smarter version. It uses multiple antennas on the receiver to figure out the direction the signal is coming from, giving us that 1 to 5 meter accuracy. Why not something like ultra-wideband, or UWB? UWB is super accurate, often used in warehouses. But here's the catch. The project relies on people using their own smartphones via a mini program. Standard phones don't have UWB chips, so it wouldn't work. Bluetooth AOA, however, can leverage the existing Bluetooth capabilities in most modern phones. It's a practical choice, though implementing it well requires some technical know-how medium difficulty, as they put it. Okay, sounds promising, right? Hold on, there are some major plot holes we need to fill before we commit. Imagine trying to plan a treasure hunt without a map. That's kind of what missing the site drawings feels like. We need detailed blueprints to understand every nook and cranny, especially those areas blocked by metal where signals might bounce weirdly. Then there's the floor height. Knowing if the ceiling is 10 meters or 15 meters changes everything about how we place our sensors and antennas. Higher ceilings mean potentially weaker signals reaching the floor, requiring more hardware or clever placement. Finally, photos. Not just any snaps, but comprehensive images showing the actual layout, the density of metal structures, the level of dust everywhere. These aren't just nice-to-haves. They're critical for figuring out how many devices we'll need and where to put them for optimal coverage and accuracy. Without these, our budget and deployment plan are just guesswork. And here comes the biggest roadblock, the elephant in the room. The mobile signal inside the plant is basically non-existent. Think about it. You're trying to run a navigation app that needs to constantly send data back to the cloud server to calculate positions and provide directions. If the phone can't even talk to the network, the whole system grinds to a halt. No data upload, no calculations, no navigation, no reverse positioning. It's useless. This isn't just a minor inconvenience, it breaks the core functionality. So, what do we do? Option 1. Tackle the symptom, figure out with the client how to boost the cellular signal inside the factory. Maybe install repeaters or signal boosters. Option 2. Redesign the software approach. Can the mini program work offline? Could it process location data locally on the phone and only sync when a connection is available? Or maybe find another way to get data back to the backend without relying on the cellular network. This communication failure is the priority number 1 issue that needs fixing before anything else. So, wrapping up, the immediate next steps are clear. Get those photos, see the site, understand the obstacles. Talk about the network problem, figure out if we fix the signal or adapt the app. Once we have all the crucial info drawings, heights, photos, and a plan for the network issue, we can finally crunch the numbers. How many Bluetooth AOA devices do we need, and what will it cost? Keep the lines open, keep communicating, and move forward.